To achieve a complete synthesis of the rules of logic with the concept at hand, we need more than those four laws of thought and the rules of replacement which fall under them. More specifically, the atomic quantifier. What atomic quantification is, plainly, the ability to determine specific conditions recursively. For instance, taken as our example the concept of vehicle that we've explored earlier. If we say that every biological process contains vehicles that handle the movement of nutrients throughout the body, or that every economic system has a vehicle by which to handle the movement of resources throughout the system, then we can say that our recognition of the seeming pervasion of the concept and our continuous importing of the concept in different domains really stems from a direct quantificational application. It is through quantification that we can apply concepts at all, let alone as creatively and flexibly as we see here. As far as logic is concerned, the very capacity to apply non-contradiction or identity to the concept of vehicle is already quantificational. But quantificational in that it involves application. Application is important. The fact that we're able to analyze the concept at various levels of complexity, and at endless levels of complexity, by the way, stems from the fixed manner with which the precepts of analysis can be continuously and progressively reproduced with respect to the concept. We're quantifying in that the precepts, which are the rules of inference, by the way, with which we've rendered the concept analyzable in the first place, and by which we've formed our mento concipio, are reproduced recursively, and, as it were, asymptotically.
All progress in conceptual knowledge and pure theory consists precisely in surpassing this first sensory immediacy. The object of knowledge recedes more and more into the distance, so that for knowledge critically reflecting upon itself, it comes ultimately to appear as an infinitely remote point, an endless task. And yet in this apparent distance it achieves its ideal specification. Ernest Cassirer, A Philosophy of Symbolic Forms. This is pretty much the abstract, conceptual sense of what physics calls the electromagnetic repulsion between atoms.
The vehicle can now be thought of in terms of any state in which it already is, and any possible extrapolative state in which it can exist. The utility of this rule is actually found in its use in quantum mechanics. That a particle can be in a 0 or a 1 state is an application, that is, a quantified application of the law of non-contradiction, and is essentially a mechanical form of the Socratic maxim.
I know only that I know nothing.
Through this application, we continue to introduce and reproduce the condition of undecidability to the system. The purpose of undecidability is simply to give way to definition, and indecision is an expression, in different terms, of the principle of identity. Thus we say that it's the vehicular in vehicle that we maintain as undecidable, insofar as the possibility is maintained of describing or determining the vehicular mode of some object, that is, the form in which the mechanism of transport in general may articulate itself in nature or in systems of nature. Now, more complex renditions of this principle can be obtained, and as evidence of the reality of the specific quantifier we're using here, we note how progressively more differentiated and complex expressions of our example, the vehicle, can be derived. There's really no definable limit to the scheme, and this indefinability of the limits of our knowledge, albeit with respect to some definite concept, is how we're introduced to the rule of quantification.
Let me add to this. I worked in aviation. I got a great example. For example, the spatial references, up, down, left, and right, If we take up as a rule, we are restricting ourselves to relations or conceptions to do with ascension, elevation, altitude, heights, and any spatial relations that fall under these. The case is likewise with down. Here appear concepts of descension, depth, de-escalation, etc. What we're quantifying here is not any of these spatial modifications, but the general rules whose modifications they are, that permanent form from which all these spatial perspectives are derived. Precisely in this sense, quantification is to be understood. Quantification answers the question of how we express ourselves within the spatio-temporal domain which the rule of inference constructs for us. Quantification is not just the bare spontaneous act of assertion, but it really shows when it judges according to and in line with the context of the rule. To assert that the Mariana Trench is over 5,000 fathoms below sea level, we're quantifying by way of the spatial concept down. If we say that Mount Everest is over 8,000 meters high, then we're quantifying by way of the spatial concept up. These are judgments in Kant's sense if we take as the universal the concept down or up. They would be universals in the sense which universal quantification discloses. This would be a deictic form of quantification. But quantification nonetheless, since its basis is logical. A quantifier in the logical sense would be that device by means of which we determine objects through the modes constructed by rules of inference. Since we've defined 4 such rules, we infer to the same extent that there are 4 distinct quantifiers, one for each rule of inference.
Thus we have here a diagram, every aspect of which fulfills a specific function, so much so that any instance of a rule presupposes all the others, in that the possibility of occurrence necessitates and involves all its requisite conditions of occurrence. So the proposition that infinitely many forms of the concept ni'mah, or vehicle, can be obtained is a non-contradictory proposition, insofar as the concept remains definable and analyzable for us, no matter its simplicity or specificity. Its openness to analysis ad infinitum is a joint product of the rule of modus tollens and the atomic quantifier. The relation between atomic quantification and modus tollens can most clearly be seen here. For instance, we say that the occurrence in itself, being an application of a rule, is quantificational, the specific type of which is atomic, and the domain or field in which all components seem to converge upon some limit that we can't seem to reach, i.e., the infinity of possible representations of the idea of vehicle or ni'mah, involves the rule of inference modus tollens. More than a mode of judgment, a rule of inference is more like the constancy of the conditions to which is owed the uniformity of the mode of judgment. Thus we say whenever we see dark clouds, there is a high chance of rain. The term wherever reflects the permanence and continuity of the idea, to which, by the way, we don't really assign a limit, recognizing that the point is not such as would benefit from a limit or even require it. The limit is the idea itself, and the idea is perceived here as an idea sub specie eternitatis. That is, it has its place in the universe, and by extension, its meaning can only be exhausted when the whole universe of ideas is exhausted, which is impossible in the static sense, let alone in a universe where ideas evolve, and by extension the implications of such ideas. The atomic quantifier, nonetheless, secures for us the possibility of determining the idea, however complex it is. The specific import of the rule of inference appears here, that it can adopt such a mode of thought and think schematically and unchangingly about the continuous possibility of this rule is modus tollens. It's paradoxical, but only when we confront the rule, because what happens is that it gives rise to self-reference. Think of the famous Kantian proposition that the conditions of the possibility of experience in general are at the same time conditions of the possibility of the objects of experience. This here is a self-reference that is in no way paradoxical, because it's used correctly. And it's used correctly because it's here expressed as a rule of thought, a rule of inference. When properly applied, we get statements like those expressed by Leibniz and Kant. There is expressly no limit to what we can define in our object. Leibniz and Newton based their calculus on this principle. The self-reference is actually the strongest example for quantification. The very illusion or reference to a rule is quantificational in the proper sense. Self-reference is not paradoxical. It's how rules sound like when in propositional form. The very introduction of a rule is atomistically quantificational, let's say. The idea of some rule or principle according to which certain relations conform is quantificational, because we present the law or rule. We are acting, judging, representing, though the rule may be as old as Aristotle's logic.
This is what the biggest philosophers have grappled with, believing that self-reference is some sort of problem in need of solution. They didn't see, at least not until Kant, that it's an essential function of the mind. Precisely that function through which we represent the conditions of knowing something. The perception of paradox is actually evidence of this. The impulse of finding a solution is the logical, critical mass that presents for us the purest and most basic expression of the possibility of knowing, because the possibility of knowing is the possibility of knowing something, as Kant correctly puts it. Leibniz put it best when he says that. This principle is not simply a law of nature. Rather, it is a universal law showing us how we are to find and to grasp natural laws. In fact, it's due to the formalization and understanding of this principle that the invention of the calculus was made possible. The central thesis of the calculus is the postulate of continuity, of infinity, and what's held to be infinite is nature, the world, the universe. For insofar as these are individuals, and since our mind comprehends the notion of infinity only as a sign or predicate, it can thus only be predicated of individual simple things, which means that we're subjecting those simple things to the postulate of absolute continuity, to finding its precise place in the chain of being and how it relates to every relatable idea. This postulate enables us to analyze its parts and the parts of its parts and any derivable component of it, insofar as they all bear the stamp of the thing. Hence the idea of the infinitesimal. What appears as an unlimited subdivision does not aim to reach an indivisible, irreducible point, but simply to fixate, as an illusion, the idea of a limit so as to maintain this objective relation to the object. We can here speak of modus tollens as the framework or space in which this movement unfolds.
Remember when we said that it's possible to know what rules fall under what rules, being structurally alike? Well, modus tollens and non-contradiction exemplify this idea, and they do it precisely owing to the mediation of the atomic quantifier. The latter saturates its meaning by providing the concrescence, by which all the conditions requisite to some function in general are made possible. So what is non-contradictory about modus tollens? Or vice versa? We summed this up in one word: undecidability, and noted how quantum and statistical mechanics rely on this conception. But the best expression remains that of Socrates, who presents it in the ethical formula: the unexamined life is not worth living. Physics hypostatizes this in the dimensions of space and time, using undecidability as a central axiom.
In Einstein's thought experiment about lightning and a train, this principle becomes magnificently evident. The experiment reveals how different observers can simultaneously hold seemingly contradictory perspectives that are nonetheless simultaneously valid.
Imagine two observers, one seated in the center of a speeding train car, and another standing on the platform as the train races by. As the center of the car passes the observer on the platform, he sees two bolts of lightning strike the car, one on the front and one on the rear. The flashes of light from each strike reach him at the same time, so he concludes that the bolts were simultaneous, since he knows that the light from both strikes traveled the same distance to his eyes at the same speed, the speed of light. He also predicts that his friend on the train will notice the front strike before the rear strike, because from his perspective on the platform, the train is moving to meet the flash at the front and moving away from the flash at the rear. But what does the passenger see? As her friend on the platform predicted, the passenger does notice the flash from the front before the flash from the rear, but her conclusion is very different. As Einstein showed, the speed of the flashes as measured in the reference frame of the train must also be the speed of light. So, because each light pulse travels the same distance from each end of the train to the passenger, she can only conclude one thing. If she sees the front strike first, it actually happened first. Whose interpretation is correct? The observer on the platform, who claims that the strikes happened simultaneously, or the observer on the train, who claims that the front strike happened before the rear strike? Einstein tells us that both are correct, within their own frame of reference. This is a fundamental result of special relativity. From different reference frames, there can never be agreement on the simultaneity of events.
Non-contradiction is introduced as the structure of the understanding, as the general condition of mutual exclusivity necessary for learned reference. To apply it is to produce the dual structure we showcased in the beginning. To put it in the simplest way, this is what enables us to conduct thought experiments, and this requires that the object and the analysis thereof be compresent and coextensive. This isn't as straightforward as you may think. It's actually very complicated. There must occur a conjunction between the object and its analyst for the thought experiment to begin to take shape. Many of us would not have noticed that there was a fundamental time difference in Einstein's thought experiment. Einstein applied non-contradiction in order to generate the two mutually exclusive perspectives or reference frames. They are mutually exclusive because two different yet valid conclusions are reached. The observer outside the train, observing from the platform, and the observer inside the train would see things differently. But the difference remains relatively true for each. The conjunction can be seen in the tension between the two perspectives, a sort of tension whereby one's almost forced to make a reductive conclusion, to assert one as true and omit the other, but cannot. What gives rise to each perspective or reference frame is precisely the other. Non-contradiction provides a very specific form of restriction where the different observations automatically and naturally feed back into each other, producing a compact sequence of judgments wherein only those conditions requisite for consistent and precise objectification are taken into account.
The axiomatization of this concept, in turn, can only be made through the triadization we see here, in this category, by implementing more or less the calculus method, by having non-contradiction and the extensions provided by the rules of absorption and tautology as our integral, the rule of modus tollens as our constant, and the atomic quantifier as the derivative. Now we can see how non-contradiction is the ground of the relation, and how modus tollens describes how the elements within the space behave, and how we establish the link between them, between the space and the elements functioning within it, as our atomic quantification. The quantifier provides instantiations of the system at large. But why the calculus method exactly?
I got this one. Working in aviation teaches you a thing or two about the crucialness of the calculus. the calculus allows us to analyze and model continuous change, velocity, acceleration, fluidity, etc. If you translate this into the language of logic, you can see how our continuous ability to analyze propositions of a certain sort, such as the continuous possibility of analyzing propositions itself, then we can immediately see how the method of the calculus is important. In fact, the calculus itself is but an expression of the logical construct formulated here, simply because before we can talk about tracking the velocity and position of a rocket to determine where it will land after a successful launch, or how the air flows over different curves of an airplane wing, or the exact production quantity for maximum profit, or how a bacterial colony grows in a petri dish, we must determine the sense in which we are going to arrange our objects. This structure is everything, and it's only the structure which our cognition assumes with respect to the objects of experience.
This cognitive structure is logical before it is mathematical. That is, it is qualitative before it's quantitative. It's a logical expression of the coordinates x, y, and z. The first appeared in analytic geometry, i.e. the Cartesian coordinates, what allows you to analyze some concept continuously, say the exact production quantity that maximizes profit, by finding the derivative of the profit function is simply this, the non-contradictory ground of the process, in which what exists, i.e. the numbers that appear to you in a sequence, and what could exist, the numbers that could be represented in the sequence, are made the most basic condition. But note that there are no numbers here yet, just a general topological spatial continuum onto which the numbers are projected. This is our integral.
You can understand this by analogy to the Higgs field of quantum mechanics. The Higgs field represents the underlying, pervasive quantum field that permeates all of space. It is not a directly observable entity, but rather a theoretical construct used to explain the observed behaviors of particles. When we say that non-contradiction is an integral, we mean by it that in which certain phenomena, in our case cognitive and propositional tendencies, are hosted or contextualized, as we showed in Einstein's thought experiment. Remember that an integral is only a kind of repository. The discrete elements or rates of change are integrated within the slope, or the line, or the curve, or whatever this larger domain is in which change is registered.
Now we introduce into this our constant, the rule of inference, modus tollens. This is to govern the general state of the numbers in a sequence, how they behave, based on the structure provided, i.e. non-contradiction. This state is not the same as the integral of non-contradiction. How the numbers are understood to behave is different from the underlying cause for their behaving that way. Inasmuch as the force field is distinguished from the elements by whose strange behavior we come to be aware of the field. The quantifiers are derivative, as we said. In the calculus, the derivative is what gives us discrete accounts of change. By subsuming the elements under the integral, the style and pattern of this subsumption is indicated by the constant, showing how the elements conform to the structure, and how the structure modifies the elements. It is thus identical to the Kantian definition of judgment, of thinking the particular under the universal. The derivative is the quantifier. It objectifies according to some constant, because it would simply be describing what it sees, and what it sees is nothing specific, but what's specific is the judgment itself, that nothing is specific. The numbers, whose analysis we now endeavor, are expedient. What's really given is the scheme, the continuity with which we register change in general, the nature and sense of this change. Without the use of numbers as our elements, we would not notice this. It would be too obvious, too given to be noticed. Only through application, only by the effort of analysis, only by exercising ourselves, do we obtain this principle? As we showed with God's name, Al-Wahhab, the consciousness of invocation gives an entirely different view. The disposition that led to the calculus is pretty much analogous to this.
And Allah has created from water every living creature. Some of them crawl on their bellies, some walk on 2 legs, and some walk on 4.
Convenient that we brought up the horse. The logic of the number is imprinted onto this animal and any animal that walks on all 4. Emphasis on continuity is quite blatant. De Morgan laws also appear here. But to relate it somehow to 4-footed movement, see how, when 2 of the 4 legs are active, that is, touch the floor, the other 2 are on standby, and their roles are traded on this basis. The reality that this functional pattern is built on the rules of thought, particularly non-contradiction, is self-evident. 2 contradictory statements cannot both be true in the same sense at the same time. Simply replace contradictory statements with the objects, the pattern of movement of the horse's legs. When the front legs are extended and pushing off the ground, the back legs are lifted and moving forward. Then, as the back legs come down and push off the ground, the front legs are lifted and moving forward. God uses the number 4 in this precise conceptual sense. How the number shapes the relations functionally, the mode which functional systems take. We'll explain this shortly. It's a qualitative rather than quantitative, or let's say the quantitative in it serves only to make it recognizable, and from the recognition of the quantity, the quality associated can be deduced or inferred. Zeno's famous paradox of Achilles and the tortoise reveals an essential truth about the nature of continuity. As Achilles races to catch up to the tortoise, he is perpetually hindered by the infinite divisibility of space and time. No matter how much ground he covers, the tortoise has moved ever so slightly further, creating an unending series of gaps for Achilles to traverse. Rather than viewing this as a limitation to be overcome, the paradox points to the self-contained, self-perpetuating quality of continuity. The race between Achilles and the tortoise is not a linear progression with a definitive end, but a closed loop of perpetual motion. This paradoxical dynamic is the very essence of continuity itself. We see similar principles manifested in the animal kingdom. Quadrupedal creatures, with their stable, efficient 4-limb gaits, embody a more inherent sense of continuous, uninterrupted movement. Their biomechanics lend themselves to a flowing, generative momentum that is disrupted in bipedal organisms like humans. The bipedal stride requires active effort to maintain balance and control, breaking the seamless cadence of quadrupedal locomotion. This theme of continuity also finds expression in the legal system, where witness testimony is judged not solely on its plausibility, but on the witness's ability to steadfastly maintain their account in the face of scrutiny. It is the persistence and consistency of the witness's narrative, its capacity to stand firm under the court's examination, that lends it credibility, a kind of mechanical continuity akin to the perpetual motion of Zeno's race or the gallop of a 4-legged animal. What matters is the duration within which the testimony takes place. And if we restrict our judgment to this criterion, then the consistency of the testimony coincides with the inability to refute it. If the testimony stands, then it has not been ceased through the only way of ceasing it, which is to disprove it. We all know the saying, innocent till proven guilty. Are we not particularly aware of the continuity of the state of innocence that's maintained? We're suddenly aware of the lingering duration of innocence, of its persistence. Does it not impress itself strongly upon the person who's at the clutches of the justice system, of the person who's waiting to hear back from a job, or the person waiting in a lobby? or the impatient student who's observing nervously the ticking of the clock for the period to finally end, the uninterrupted continuum in any of these cases becomes a powerful psychological and existential reality. Thus, the assertion of 4 in this context is particularly emphatic of this feature. Even in our conceptualization of time, the number 4 often denotes this quality of indefinite continuity. When we speak of the passing of years, we invoke a duration that is open-ended, self-repeating, indefinite, tedious, inconclusive. Like the infinite regress of Zeno's paradox, the progression of years is a continuum, a generative force that flows onward without end. Through these diverse examples, from the thought experiment of Achilles and the tortoise, to the biomechanics of quadrupedal versus bipedal locomotion, to the persistence of witness testimony, to the very notion of time itself, we glimpse the profound significance of continuity as a unifying principle underlying the fabric of reality. Far from being a limitation, this inherent quality of self-contained, self-perpetuating processes lies at the heart of how we understand and engage with the world. But the essence of continuity is continuity for itself, continuity as conceived by the mathematician. It demands that we contemplate only the process and not the end to which the process is directed. As Samuel Alexander noted, if it be asked what is there in space points, which makes them continuous, we are asking a different question from the question what is the criterion of their continuity. Recall Newton's first law. A body stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced external force. This is predicated on the sense of continuity we've been discussing, which itself is predicated on a higher law. This is modus tollens. Modus tollens meaning mode of denying.
Help us understand exactly what modus tollens means and how it functions, because it seems to mean more than the conventional definition gives. Since we're speaking of the calculus here, can you put it in a mathematical analogy? How would I, as the subject, experience this rule?
Sure. If a statement is true, its consequence must be true. If the consequence is false, the original statement must be false. For example, if you're a dog, you're an animal. You're not an animal, therefore you're not a dog. As previously noted, by defining the class under which some concept falls, you, by extension, define the concept. The reverse is correct. Denying the class denies the concept. The denial must not be understood as a denial of the concept itself, whatever it is, but rather as a general abdication. It's logic's way of determining the subject who determines. And it does this by determining the condition specifically prior to any determination. It must show this process as a stripping away, a letting go, a removal. In order to remove that condition, which would otherwise render the concept a specific concept, thereby eliminating the subject through a synthesis with the object. It's a denial because the denial forms a spectrum, and modus tollens is an assertion of that side of the spectrum that precedes any assertion, which would be modus ponens. It's a spectrum because the denial, though meant to deny any specific assertion, is itself an assertion, a metalogical assertion. And it's precisely the mode of thought required to conceive of something in itself, as we did continuity. To conceive of the idea of a regress, or self-containedness, as Newton does in his first law, requires the rule of modus tollens. Because the self-reference we see is only a mimicking of the mode which you, the subject, already assume. The difference in modus tollens is that we are provided the abstraction necessary to assume the concept, whatever it is, as though it is the subject itself. Subjectivity can be thought of as whatever conditions the object, whether it's the subject itself, you, or some mode which the subject assumes in order to determine the object. This appears most clearly when we do thought experiments, because we're here particularly aware of the space which we operate within. This rule is widely used in applied mathematics and physics. It's called the imaginary unit. A constant which allows us to determine the initial conditions of any system whose transformations we are observing. It's framed this way as a syntactic convention. The best way to explain it is by denying any specific explanation, permanently, or as we did in our mathematical analogy, constantly. A false proposition, as Russell put it, implies every other, or false propositions imply all propositions. And true propositions are implied by all propositions. The first sense represents something like the first enunciation in the space-time dimension of non-contradiction. To enunciate is to already be in said dimension. Thus the syntax simulates how one may express themselves should they find themselves in this dimension. Call this dimension the continuum dimension. So, Eureka, this is the first coherent sentence articulated in this dimension. If you think about the trajectory of a car or a plane, you see an uninterrupted straight line, a continuous moving forward. Now, remove from this situation or abstract away all other ideas that tells us what's moving in a straight line, how fast it moves, how it moves, what it's moving towards, and you obtain the idea of continuity.
We can see how the rules of logic can be shaped by the calculus method. But is the opposite also the case? Can the calculus be shaped by logic?
Absolutely. The calculus is already logical. It is logic applied to quantities. The logical in the calculus is the structure, as given by the notation, the order in which the elements are to be arranged. The mathematical is the values obtained when this structure is applied to objects. If you're asking whether logic can be made mathematical to the same degree, you'd be invoking Leibniz's logical calculus. And the answer is yes. It would then be possible to produce logical propositions with the same mechanical accuracy as the mathematical calculus. This would complete mathematics. The classification we've constructed in this module is a massive leap in this direction. The key thing is that our constant, integral, derivative are the conditions of knowledge itself in general. Functions of the mind, cognitive structures, and what we determine is nothing but the rules of logic themselves. There are weights, to use a neural networking analogy.
In logic, our constants are rules of logic. More specifically, those more general rules that can be understood as classes under which other rules fall. As such, in logic, constants are real constants, as opposed to the general initial condition with which we usually start our mathematical calculations. If we try to marry logic up with our experience of things, or logic with mathematics, as used conventionally, then modus tollens would represent all constants obeying this structure. Here, all our elements behave in the manner denoted by the formula of modus tollens, that relation which in non-contradiction is presented in its purest form. Call non-contradiction simply that principle which emphasizes difference in sense, as we showed earlier with the four-footed animal analogy. It becomes a condition of the very objects with which our analysis deals. Every object conceived under non-contradiction is inferred as both possible as well as valid/real. That is, the object is taken in its full sense. Let's take the example of the universal quantifier in relation to the hypothetical syllogism. A hypothetical syllogism says that if Socrates is a man and men are mortal, then Socrates is mortal. It makes an immediate, indirect assertion about something. If we say that a hippopotamus is an amphibious animal, then we directly infer that based on what the notion of amphibian involves, that hippos are well adapted for aquatic movement in life, and anything which may characterize the general idea of amphibious. Now, a universal quantifier allows you, in this context, to state anything which can be predicated on the concept at hand, based on the underlying nature of the thing. That is, the nature of the thing is predicative and or implicative of anything to which this nature pertains. In the idea of man is contained all those propositions which are generally true of and unique to man, those we know and don't know. those innumerable things are assertable and determinable a priori through the universal quantifier, we obtain a class of implications, as Russell would say. The Quran uses this quite a lot.
Every time Zachariah saw her, he saw that she was well stocked. When he asked her where she got all that, she'd reply that it's from God. He provides whomever he pleases with no return. All food was lawful for the children of Israel, except what Israel made unlawful for himself before the Torah was revealed.
All food was lawful for the children of Israel. The word kul, every, is actually a quantifier, much like kullama. In verse 25 of chapter 2, God uses the expression in its true a priori sense. When we say kul, every, in relation to what's given, like food in this example, we're stating the viability of all potential types of food. Potentiality is intrinsic here, as the expression all refers to what one is already subject to experience and encounter, a priori. When we say everything, we don't mean everything in a sense that's universal for everything, but only in a sense in which universality is restricted to our individuality, the specific universe of the individual. It's a subjective universality. It's all that which you, the subject, are exclusively subject to experience.
Just like the continuum dimension, this too is a dimension. I call it the discreteness dimension. The same structure we discovered in the case of non-contradiction is reproduced here. The integral is the law of excluded middle, the constant hypothetical syllogism, and the derivative is the universal quantifier. We judge the universal validity of some object because our objects in this dimension are simply embodiments of laws. Nothing here is directly what it is. It is the law of which it is no more than the representation. This is a problem, just like the indeterminacy of the objects, so to speak, of our continuum dimension. Our recourse is thus to make the grossest generalization possible, and it is that all objects there are embodiments or personifications of laws or orders. The generalization we make reflects the function of the integral. The constancy is how objects appear to behave, and our derivatives are our judgments regarding the discreteness of our objects. It is Allah who has created 7 heavens and of the earth, the like of them. His command descends between them, so you may know that Allah is over all things competent, and that Allah has encompassed all things in knowledge. See how the heavens and the earth have become discretized into several planes. The discretization, as in the breaking down of the heaven-earth monolith, is akin to a process of derivation or quantization, essentially, of emphasizing the magnitude aspect of this system. The phrase kulli shay'in in this context points not to some subjective angle, but to absolutely everything which God has created. Since it's God who posits this, and God's perspective is the perspective, and his sense of everything is truly everything, what we commonly think of as subject as well as objective. This is necessarily parochialized in the subject, because the subject is only a certain reference frame of the totality of the universe.
The same relation is found with regards to modus ponens and the existential quantifier. The latter states that since P implies Q, if P is, then Q naturally follows. And P is any concept which some proposition falls under, and Q is that proposition. For example, if we formally acknowledge that dark clouds imply rain, then it follows that the presence of dark clouds automatically entails the idea of rain, and vice versa. This is equivalent to the hypothetical proposition. The existential quantifier here allows you to assert either state, the rain or the dark clouds, interchangeably. There's no predicability in the same sense as the hypothetical syllogism. but rather only the duality of the given ideas in relation to one another, between which the assertion oscillates. An example of this is verse 28 of chapter 1. The quantification moves here between the possibility and actuality of the same underlying concept. If we take life and death as fundamentally one concept, the unity that underlies them is indispensable and is what's presupposed by these assertions. At the logical level, there's no actual states like life and death, but rather non-contradictory propositions of truth and falsehood, of the possible and the actual, which through discourse we dress up as life and death, high and low, light and dark, analogous to how the calculus, through its own concepts of the derivative, constant, and integral, is applicable to many fields.
You were lifeless, and he gave you life. Then he will cause you to die and again bring you to life. Then you will be returned to him. 2:28.
You were lifeless, and he gave you life. Then he will cause you to die and again bring you to life. Then you will be returned to him. Another expression of this is found in verse 5 and 6 of chapter 94.
Surely with hardship comes ease. Surely with that hardship comes more ease.
So surely with hardship comes ease. Surely with that hardship comes more ease. We observe here a didactic employment of this logical rule. The affinity and mutual inclusivity of two ideas, life and death and hardship and ease, are interpretable such that one may elucidate the one, and the one obscure or anticipate the other. The didactic sense accounts for both, and serves to inform us of the lawfulness of the dynamic. The disjunctive syllogism is baked into modus ponens, whereas modus ponens gives us the general idea of the associativity of two propositions, such that one may be inferred from the other. The disjunction essentially absolves us from any definite choice of assertion, only giving us that indecisive vantage point from which we can then infer the relation of one proposition to the other. This can be understood in light of the above verses. The order of propositions of life and death, of hardship and ease, though expressing a modus ponens, when we confront the fact that the order is not definite, but rather reversible, we see more of a disjunctive syllogism. The quantifier linked to the disjunction is not one that's usually recognized or treated as a quantifier. Much like the atomic quantifier is not considered a quantifier in modern logic. It's negation. Call it negative quantification. And what it does is enable us to define a specific condition from which specific relations follow. For example, in life and death, the negative quantifier is applied to their synthesis, that general idea or concept which they both fall under, and which their relation generally conveys. Now, the synthesis is not immediately obvious or even declared, yet it's nonetheless there and preconditions the relation. That it's not obvious, yet is defined, exquisitely captures the meaning of negative quantification. It is quantificational in the sense that it must be asserted or applied, rather than taken as given by itself. We do this all the time, by the way. Think about how, in trying to understand a certain random event, we always presume that we can understand a phenomenon or event without knowing all of its preconditions, or the whole story, as it were. We say there is a high chance of precipitation, while being utterly oblivious to the background processes involved in precipitation, the minute reactions and details, which we cannot know, but which, if we knew, would allow us to predict the weather much more accurately. We apply negative quantification when we defer the background, the explanations, the minutiae, those hidden infinite factors that we cannot account for. In throwing dice, says Heisenberg, we do not know the fine details of the motion of our hands, which determine the fall of the dice, and therefore we say that the probability for throwing a special number is just 1 in 6. This is an example of negative quantification. The difference to unknown factors, as appears heavily in quantum and statistical mechanics, rely heavily on this principle. But long before these fields were established, philosophers have grappled with the idea. Descartes, for instance, expresses it as a solution to the problem of infinity, saying that, however difficult to comprehend, the infinite is known or apprehended directly and before the finite things which are easier to comprehend. But to see the quantification and distinguish it from a regular assertion, the inference to the prior condition must be intentional. We must deliberately point out and refer to the fact that there is such a thing as a background, as a formal state. This is epistemologically indispensable, for in asserting and making known this background, like Heisenberg's case, the fine details of motion of our hands, or in Leibniz's case, all the sides of a chiligon, we're really formulating a necessary condition for the comprehension of the object in general. We have to start somewhere, and that somewhere cannot be the full, irreducible reality and sense of our object. No, but only always some instance or mode of it. We need this initial limitation and incompleteness to begin the analysis at. And accompanying the cognizance of limitation, the simultaneous cognizance of those obscure aspects that await exploration or explanation. We usually express those hidden aspects by a sign that negates the object of our understanding, and by negating it in some manner as to represent it as a problem in the process of being solved, or an insufficiency in the process of being sufficed. But at any rate, it must be understood as a process.
Let's go back to the relation between existential quantification and modus ponens for a second. In this dimension, which I call the monothetic dimension, objects are much more specific than the fourth dimension. Objects are indicated by other objects. A thing seems to be related to some other specific thing or identical to it. There's nothing individual in the sense we're familiar with, which is the sense given in the discreteness dimension. The individual is what two or more things have in common. The common denominator is what's individual, and it's in no other form than that diffused sense. Here, even the common denominator, when grasped in its identity, is identical through other relations. Bradley's regress describes exactly what goes on in this dimension. Again, this is the grossest generalization one can make in this dimension. If we say object A is related to object B by relation R, then we need a new relation, R1, to connect A to R, and another relation, R2, to connect R to B. But then we need more relations to connect those relations. This creates an infinite chain of relations. The book is on the table. Book A and table B are connected by on, R. But then, how is on connected to book? We need another relation. How is on connected to table? We need yet another relation. This continues infinitely. Say, He is Allah, the one and only. Allah, the eternal absolute. He begets not, nor is he begotten, and there is none like unto him. This passage illustrates the complexity of identity and relationality, demonstrating how a concept can be defined through its non-relations and absolute singularity. The identical in the verse is God, but we're acquainted with God through his attributes. If P then Q, we can think of each attribute as being Q, and God as P.
Regarding the disjunctive syllogism and the negative quantifier, I would add the following. This dimension, which I call the flux dimension, is the strangest of all. We see neither embodiment or commonality. There's simply what can be described as transitions, much like a sketchbook pages. We pay less attention to the states than to the procedure of these states, the indefinitiveness of states, the flowing, the progress. Nothing is fixed. The identity is not what's common, but what's going on, what's moving, what cannot be described as being in a certain state. In other words, what's evident is the fact that things are changing.
Pretty much so. Logic likes to use the expression OR, and it atomizes this principle and makes it permanent, so that what's unceasingly the case is the indecisiveness of the case. The sufficient reason in this is clear. Transitions and dispositions here are generally expressions. Of the form, the shortest path between any 2 points is a straight line. The transitions aren't random at all, but animations of laws or probability distributions. It's in no way a Heraclitean flux, but a flux in which movement are describable by the principle of least action. Leibniz, to whom this example famously belongs, saw this optimization in nature as evidence of God's perfect design, where things naturally follow the most efficient paths. This is sufficient reason operative as the integral of the relations of the elements within this space. Newton's fluence and fluxions also corroborates this view. Every dimension borrows from and lends to the other, a feature that it lacks, and in so doing it completes and is completed by it. As you see, continuity requires identities, transitions and discrete states. The monothetic dimension that describes identity borrows from the flux dimension to define the change common between 2 or more states. States which it in turn borrows from discreteness, a definition which it constructs from the condition which continuity gives it. Nothing really truly belongs to it. It is a mesh of all the others. The flux dimension borrows from discreteness states between which it can showcase movement, a movement that requires monothetic identities, the connections of which it affects. It transforms random states, discrete states, into identities, thereby connecting them meaningfully. It borrows from continuity, this determinacy. Discreteness borrows from monothetic identities, those commonalities whose specific components it discretizes, and it borrows from flux the transitions between those monothetic identities and the discrete states it lays out. And it borrows from continuity the constancy with which those discrete states are generated. We noted how God, when he created heaven and earth, he partitioned them into 7 heavens and 7 earths. We find in chapter 41, verse 12, that he assigns to each of them its task. Here, we get a glimpse of what the verse may be alluding to. Firstly, the heavens and earth, in being numbered, are described as magnitudes, much as we do when from some general concept like liquid, we move to water, oil, juice, milk, etc. Those are magnitudes of the substance liquid. Now, think of the number 7 as a modification of said magnitude, a qualification of the extension ascribed to the substance. But why 7 and not 8 or 10? This taps into the qualitative understanding of number. Number is brought back to logic, and natural or whole numbers are simply rules of logic. They are deductions of the laws of thought. 7 here is the rule of transposition, which, together with the rule of associativity, define the law of sufficient reason. Simply, notice how in a complex enough system, the components are related to each other at every level. The parts of a whole are all related to each other, a relation that transcends distance. Water may form a puddle, it may be vapor, steam, or ice. It may burst from the ground or be deposited by the clouds, but nonetheless, it's water. The heavens and earth, as the Quran describes them, subsist the same way. they may describe the general structure of the universe. But through the extension of 7, we understand something more systematic about their relationship. Clearly, the Earth is not one characteristic shape. It's composed of different topological and geological expressions. Yet it's still the same Earth despite all the diversity we see. And its core principle and function persists across all those states. The same idea extends to the heavens. We can understand that the task which God assigned to each heaven is akin to the function which each dimension described above serves the others, providing a feature which the others lack, and the others mirroring this with respect to their own.
A major principle in Islam is based on this function, belief or iman, because the idea here is that since, as Hayedagger notes, we're thrown in the world, subject to and surrounded by forces we don't understand, situations and circumstances we didn't choose, and that we mostly don't understand what's happening, and most of what we know is happening, Iman appears as the antidote, saying that in such situations we must exercise faith, faith in the rationality of the world, that what seems a chaotic and irrational world is governed by a rational force, a rationale whose complex workings we could only faintly intuit, but best yet confide our reason in, being that, as Borges put it, for the machinery of the world is much too complex for the simplicity of men. It's not that the world is irrational, it's that so much must be grasped by us before the world can make sense, in the sense that we presuppose when we declare it irrational. The fundamental incomprehensibility of the world is part and parcel of being in the world. Iman rationalizes the irrational and maintains that there's a structure, but that such a structure, though could be comprehended through revelation, must still be founded on belief and rest on it as the vehicle by which to navigate the uncertainties of the immediate, which, like negational quantification, is a mechanism by which we defer judgment regarding the nature of the immediate, the not yet rational. But when we defer, we always defer to, namely to something rational. Such is the function of Iman.